Okay, here's my data. I put a ball on a ramp, and I let it fall down the ramp and hit a cart. And then the cart moved forward and rolled for some amount of time. I changed how high the ball was when I let go, and I recorded the time for the cart to stop, from when it was bumped to when it stopped rolling. And here's my data. Now, first, there's a few things I have to fix. I can't just put h for height. I have to type out the word height, put down a variable with italics, and then put the unit, centimeters or something. Now, we want to use metric, and meters or centimeters would be fine. A prefix here is okay. But don't use inches, that's not metric, not SI. But instead of putting it in parentheses, here's what we're going to do. We're going to make it look like we're dividing the unit out away from the value, from the height. Because then down here, you do not want units. You don't put this as 2 centimeters, because then Excel won't recognize it as a number. It'll think it's just text. So make sure you don't have any spaces, just the number itself. Also, my centimeters is getting cut off. So go to the line between B and C, this line right between the column headings, and you see that icon I have? Double click. Same here. Whoops, lowercase t for time, in seconds. Let me double click. And maybe I'll decide to give it a little more room. I'm going to highlight this, and I don't want to merge in center because I don't want to merge it into a single cell. That's not what I want. One massive cell? No. I just want to center, so I go under alignment, center. Next, these values, all of the data in a single column generally is going to be rounded to the same place. I mean, I recorded these with the same meter stick or ruler, so they should all be rounded to the same place. So let me go over to the increase and decrease decimal. I'm going to add more than I need and then take it back down. Same thing here. Next, I create a chart. You can highlight the values. Don't highlight the headings, right? Don't highlight the data, just highlight the values. And then you do insert, and it's charts. You do the scatter XY, which is the one with just the dots. And you choose the option with no connecting lines. Don't do this. Don't do this. Simply dots, no connecting lines. And I have to go in, right-click, select data, and I have to edit the series to make sure, does it have the right thing, the correct thing on the x-axis? Yes. My x-axis is this, and my y-axis is this. Whoops. Let me try that again. Sometimes you just have to delete everything and start over. Okay, so I'm going to put in a chart title. I don't know. Process data. No, it's not processed. It's raw. We have to click add axis titles, and those are literally the same as what you have. Whoops, I got that backwards. They're the same as what you have right here in your column heading, right? Make sure you have that much information. Time, t, in seconds. If your data is linear, then you can add a straight trend line. Trend line, whoops, I don't want a legend. Trend line, however, and you would have to show the equation. This trend line looks like it kind of fits the data, but it is not the best fit, because if I take this out and then remove my trend line, look at the curve that's happening here. There's definitely some curvature, some upward curvature, right? So I can get a better trend line where the data falls closer to the trend. If I do a straight trend line, something like this or whatever it had before, the data generally is going to be farther away from that trend, right? So I want to find the trend that minimizes how far data points are from the trend. And I think the best thing is something curved. So let me make a guess then. If it's a curved trend, what kind of graph curves up like that? What kind of graph has this increasing shape? a square proportionality. And if I have a square proportionality, then it is absolutely accurate for me to say, whoops, if I have a square proportionality, right, then what I'm saying is y is proportional to x squared, or specifically in my case, what's my y-axis? It's time. See, there it is right there. And what's my x-axis? Height. So if I make a graph with time on one axis and height squared on the other, now those two things are directly proportional. Time is directly proportional to height squared. It's not proportional to height. This is incorrect. This is false, right? Strike through. That's wrong. That's why I don't get a straight line from time and height graph, but it is directly proportional to height squared, so I think. So here's what I do. First, I'll just copy this, because that's easy. So I highlight, I click with my mouse in the middle. I don't click the edge, right? Don't click the border, because then I'm moving the text. I click right in the middle of the cell, and I highlight Control, hold Control on my keyboard, and I push C at the same time. Then I can let go of Control after C has been pressed. Then I click down here, wherever I want to paste. I hold Control on my keyboard, and I hit V, and now I can let go of Control. So I'm going to graph height squared. And what happens to the centimeters if I square height? Well, they get squared too. So let me make this superscript, font, superscript. Or you can hit Control 1 on your keyboard, superscript. Oops. And here I'm just going to have time again. My y-axis won't change. And I'm going to make a second graph. Let me just put that there for a moment, since yeah, I'll go ahead and spread this out. Here's my second graph. How did I make a copy so quickly? If you click on your first graph, click on the white space, and while you're holding down, hit Control, then you let go. You can make a copy. That's a quick way to make a copy of your graph. Let go of your mouse, right? You're holding with your mouse, you click on the white space, my mouse is held down, I push Control on my keyboard, then while holding Control still, I let go of my mouse. Now I can let go of Control. Quick way to make a copy. So I want to click on one of these data points. I want time to remain on the y-axis, blue is y, and I want height squared on the x-axis. And if I see a straight line when I let go of this, then I know my data has a square proportionality. Let's see. Is that it? Oh no, I haven't squared my heights yet. So let me do equals this caret 2 squared. And then I copy that cell all the way down. And that's pretty straight, don't you think? Look at that. That's not bad. That's much straighter than what I had before. Much straighter than this. This is definitely curving, right? Clear upward curvature. Whereas this guy looks like it's straighter by comparison. So now I have confirmed, yes, this graph is confirmation that t, I can conclude finally that t is proportional to height squared. Okay. And at that point, if you want, you can put in a trend line and show the equation. Display equation. Okay. If your line is straight from the get-go, then you can jump straight to this step. What you do is you're going to leave this equation the way you see it, but when it's time to do your data analysis, right, you're going to put, you're going to describe what the graph shows as the best fit line. Y equals 0.2012 x 4267. That's a lot of sig figs. Maybe let's round it to 2 sig figs. And what we're going to do is plug in for y, what's on the y-axis of this graph? Time. And what's on the x-axis? It's height. Then we need units, okay? So here's what I'm going to do. I put open parentheses. Well, no, I don't need parentheses on that. Here, the units should be not italics. So let me click this. This is the slope. Slope is change in y over change in x. So the unit of the slope is y-axis unit over x-axis unit. So what's my y-axis unit? It's seconds, right? De-italicize. What's my x-axis unit? Centimeters. And if you want, you can write that as seconds and then do, you know, quotes around the divided by, and then hit space, centimeters, if you don't want it to turn into a fraction. Or you can say, like, under equation, there's this fraction option that doesn't put them vertically, it just keeps them horizontal. Seconds per centimeter, that looks kind of nice. And then what's the unit for my y-intercept? Well, the y-intercept is a y value. It's a number on the y-axis where a line hits the y-axis. So what's my y-axis unit? It's seconds, like that. So here is my equation. I've developed this cool fancy equation here on bottom. You only have to do this if this is a requirement, if your line is linear from the get-go. If your line is not linear from the get-go, all you have to do, oh wait, oh, my graph is wrong. This is height squared, right? In centimeters squared. So it actually would be here, centimeters squared. My x-axis is height squared. You don't have to do this if you go through the process of making a second graph. It's not required if you make a second graph. But if you don't have to make a second graph, you do have to do this. What are you required to do? If you have a second graph where you actually go through the process of getting a straight line, what's required in that case? Well, in that case, all you have to do is say, you know, the second graph confirms or blah 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 something. Make a conclusion that t is proportional to space h squared space. The final thing we need on our graphs, y error bars, y-axis error bars. So you click the plus, error bars are here, you hit the check, click on the horizontal, and then just hit backspace on your keyboard. And then for the vertical, I'll double click, do a fixed value. You're putting in half of your range for the repeated trials. So if you repeated, you know, let's say at a height of 3.5, I repeated the time 5 times. I don't know how to, this is not the best way to put it. I mean, after all, I'm not even showing units. I don't have subscript. This is not best. But let's say I have these values of time when the height was 3.5. Maybe I had 3.25, 3.31, 3.04, and 3.19. I don't know, something like that maybe. Maybe 3.31. What's the range of this data? Well, the range is the max minus the min, right? So what's the maximum? Well, let's see, the biggest value was 3.31 seconds. And then what was the smallest? 3.04. So what is that? 3.31 minus 3.04, 0.27. The uncertainty The uncertainty that I'm going to use, my error bars, is the range over 2. So this is the entire range. This is the whole span. But if you go to the middle of that range, you would do plus or minus half that value. You know, if you go up half the value from the middle, you get to the highest number, the max. And if you go down half this amount, you get down to the bottom from the center. So here's that calculation. I've rounded to 1 sig fig, and that fluctuation, that uncertainty, the half range value, that's what I would put for my y error bars. I go to y error bars, fixed value 0.1.